Welcome back to a new video and part 2 of this tutorial. In the previous video I showed how to download data for multiple realization of one model. Now in this video I will show like a workflow for like if you are handling multiple models. So typically you will be using multiple model, each will have different realizations. So for example in this exercise we are using something like more than 20 or 30 models and with about 80 realization. So how to handle different model, like a workflow for this is what will be presented in this presentation. So the outline is like workflow for downloading, and so this workflow like with downloading, because you can download, there are other way of downloading this data, like you can download it with Glopus for example, but this work flow here you would like need it not only for downloading but later on for processing this data. It will be like useful later on for data processing. So especially when you have like many models that you need to handle. So let's start by going to the data that we need to download. So this is the ESGF website, and the variable again that we are interested in is C surface height above JUID, which is ZOS, this one. And let's see, for example, we are interested in I will just show this as an example, but we can add more data later on. So let's say we are interested in the experiment, the historic 1950, like this experiment, okay? And let's see, we are interested in nominal resolution like 10 and 25. So we are not interested in like we are interested in like those with fine grid resolution. Okay, so let's see how many we get. So now we are doing the data search. So searching now for this data, like the model there. So now we have like, this is like 20 of them. So we can see like the source ID, which model 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have about 10 models. Some of these models has more than one realization, like this one has 3, this one has 6 of them. And now we want like to create like a workflow so that we can handle like these 10 model with 20 different 10 or 9 model with 20 different simulations. So let me remind you what we did in the previous video. So in the previous video we had like a single model ensemble. So if you have like one model which has multiple realizations, so we created like this general download function, and here we created this like calling function. So here like I will put like the name of my model, the source ID, the experiment ID, and then like the different realization of this model. And here I need like the member ID and the version, like where this data was stored or like created or something like this. And here's a time step, like how these files, like the time range of these files, how these files are stored. And then I pass it to this download function here. And then it will like do the downloading. Like here it will like be different, because I want this to be like, now like the institution IDs are like 10 of them, and or maybe less, because some, like if we look at the institution ID, it could be less than, like here, like this one was 10. Like if we look at the institution ID, it could be less, 1, 2, 3, 4, 5, 6, because some of these modeling groups, they could have more than one model. Like for example, here's the ESM02.5. It has like 6 high resolution model, like simulation, 6 simulation of the high resolution model, and 3 simulation for the medium resolution. Okay, so we go back here. So now, for example, like for different institution ID, different source, ID different models, and like this is the same experiment, and each one will have like a different member ID and different version. So the easiest way is just to collect all this information in a table, and then you can read this from the table. So like you can pass this, like here for example, like the institution IDs, the source IDs, the experiment IDs, the member IDs, this one, these things, like this information, you read it from a table and you pass it to your function. Similarly here, like in the calling function, like these things, the member IDs, the version, you read this also information, and all this thing, you read this from a table and then you pass it to your function. So how to create this table? This is what I will show you. So to create this table, like all the information that you need, like the source IDs, the number of files in each simulations, all the information, it is here. So you have all this information here, and if you list the file, it is more of this information is here. So how can you get this information? Like, so the way to get this information is you just return this result as JSON. So if we return it, this result as JSON. Okay, so now like we have like this information, and we can copy this URL and we can paste it here. So to convert this to CSV, this CSV is like comma separated file, and then you can convert it to Excel also. So you can choose, enter like a URL, okay, click here, you upload this one, okay, and you say like convert to CSV. So now it's converting, yeah, okay, now converting, and like you can also, you can convert this to Excel also, and here, okay, now it's downloading. So okay, so now I've downloaded the data that I'm interested in, and they should be like, it should have like 21 column, this data, okay, as we expected. It has like 21 rows, I mean. The top row, this is the heading, and here this is for my 20 different simulations. So like we don't need, like for these columns, we don't need all of them. Like you can just delete the ones that you don't need and keep the one you need. So the first column, the ID, that's the important one, because that has all like the information that is actually needed. So it has the MIP era, the activities, the modeling group, the name of the model, the experiments, the members, member numbers, the table IDs, the name of the variable, the grid information, and the version, and the node where this data is. So we can keep this one. Like other things, like like the version, for example, you don't need this because it's already contained here. So you can like delete this one, like delete this one. Like we need also to keep, so we don't need this one, activity ID, data, no, the specification data set. Like you can keep the start time and ending time. That's a good thing to keep, because sometimes, like, although this is a standard experiment, like it is from 19 like the experiments from 1950 to 2014, sometimes there are exceptions. Like for example, you see with this German model, like the high resolution one, it start at 1951, not at 1950, and end at 2010, which is kind of for the other one are like standard. So like for this, like special cases, so it's good to keep like the start and the stop time of the simulation. Other information, I think it's good to keep that. I generally would keep from this table would be the number of files and the size of each file. So you can delete this information. We don't need this one. Okay, this is the number of files, and from the number of files, like from previous lesson, we can learn something from these number of files. So for example, this one, that's like the data will be stored yearly. This one, the data will be stored like every like 3 months, for example, like because there are like 260 for like for this period from the start time 1950 to December 2014, and so this would be like 10 year, and the last file would be for the last 5 year from 2010 to 2014, so on and so forth. And if you don't, you can see this, and the size of the file, it's a good idea also to keep the size of the file, so you of all like the data, so you know like how big this data is that you are downloading. It's like a good piece of information. I think, yeah, that's it. Like I don't think that there are like other informations that you can keep. Okay, so we can delete this one, and here like for this one, let's we need to do like to further process this one. So we can come here like for this column like this, we need to further process. So you're like, you come to data and you say like text to column, because you need to separate it. So the limited, so you put like here by dot. Okay, so they put a other like a dot. You put a dot here. Okay, then next you're finishing. Okay, so we have like here now all our data, like here for example, this would be like the MIP era, for example. Here this would be the VT. Here this would be the institution like ID. This is the institution ID, like the different like modeling groups that are participating. This is source ID, like the name of the model. Here's the experiment ID, the member ID, so on and so forth. So you can continue with this table, like to reformat it, and like you can add the other data, like if you want to add other experiment, like here, because here I only added the data for the historical 1950. For the if we like go back here, like for the nominal resolutions that we are interested in, like for this resolution, we could also find something from the standard experiment for the standard historical simulation. So if we remove this one and we do search again, okay, so you can find more like with fine resolution with the standard like experiment, the historical one. I mean, there wouldn't be many of them. So like if we look the experiment ID, we go to the historical. Okay, so we find like 11 of them. Let's see if any of them has this very fine resolution. Maybe. Okay, there are like 11 of them that has a nominal resolution of 25 kilometers with the historical experiment from 1850 to 2014. And here the activity would be the CMIP, not the high resolution MIP. Okay, so you can like do the same with this data and like combine the data together. And then the final product should look something like this. Okay, so this should be like your final product, like here, like the MIP era, the activity. So here is like the high resolution MIP, or the MIP, the institution. So this is German. This is like AWI in Germany. This is source ID. So for the high resolution MIP, they have like one was high resolution and one was low resolution, and then the standard like MIP, the CMIP, the historical CMIP one, they have like several realization, and the experiment here, the member ID, the table, the variable, the version, and the node where this node is. One thing you need to know is that like the data node, one thing you need to know is that like this data node it just tells you where where's this data, like the original node where this data is, but that is different than the URL, because the URL could have like these extra things. So like under this node they could be under different directory, and that could change also. So you need, for each of these data node, you need to check like this URL. And how to do this, for example, like you can list the files, and like you can check, for example, here, and you can copy this information from here. So for example, ESGF3DKRZDE, it has this part, like it has this extra folder, threads, file server, CMIP6. So that's like the path that you would need, which you would be get here, HPC F6. I forgot to add this one. Okay, and you can do it for the rest of them here, like the number of files, the start date and the end date, and here like you can put, like, for processing this data you would need like some further information, and this one, that like this one you do manually. So you start counting, because as you see, some of these modeling groups, they start counting from 1, not from 0. Like most of them would be counting from 0, but this German model, it start counting from 1. So you see is a start counting, because when you process this data you need to account for this, like if it's start counting from 1 or from 0. The year step, so like you can check these files, like you can go to one by one of them and like check what is the year step. Is it like 10 year, like how they store this data? Do they store it 10 year by 10 year? Like here, for example, they store it for the whole simulation period, and like you see, just one file that has everything, the 65 year. This one that has 65 file means like one file for each year. This one has 7 of them. It's a historical experiment that start from 1850, so that's like each file, it has like 25 years. You see this one, like a historical experiment, it has just in one file, so in just one file it has like one, the year step here be 165. Okay, this is size. I kept here some from remember that JSON files that we converted to CVS file. I kept here also some like these 2 extra pieces of information, like the grid. So this tells you something about like the model grid, and you would like this information will be later useful for further post processing. And I kept like some information about the nominal resolution of this model, just for my future reference. So these 2, they are not like, you wouldn't need them for downloading the data, uh, but you would need them later on when you post process this data. Okay, so now like this is the file, like, so this is my data.csv file, which I'll be reading from. And now let's go, we can we just need to go here, like this download function, we need to change it a little bit. So here, this is an example, like this is a new example. I will show you how to handle multiple model. You can view the CSV file also from from here, from like the Jupyter Lab. So this is the same information that I showed you, just displayed in Jupyter Lab. Okay, the nominal resolution, the grid, and I indexed them. I just gave them a simulation index. So we have like how many simulation we have. I started from 0, so we have like 80 of them. So we have like yeah, an 80 simulation. Okay, and so like this example number 4, a multi-model ensemble, as the learning objective, you will learn how to read CVS file into pandas data frame. So here we have to load Panda. So this is, now we are using Panda. So we have to load this package Panda here. This is Python data analysis library. So you will like read this CSV file into like a data frame, you will learn how to select data by label and position from Panda, and multiple if condition if you want to have like a multiple uh, if condition, how to do so. So again, like this is my download function. I Let me first show you the calling function. So the calling function is like very simple. Like you don't need to pass all these other informations that we had to pass previously, like what is the model name, what is the modeling group, what is version, what is ensemble, because this would be all read from this CSV file. What you just need to pass here is like you here, this is data frame, so I'm reading my so this is Panda, read CSV, and I give it like the file name. So now it will like in this data frame, it will like read the data that I have here. And then I need to define the period, so I'm like downloading this data for like, let's say just 1 year. I need to display flag like what I want to display. Let's like here, let me, and here I put like a download flag because sometimes I don't want to download the data before downloading the data. I just want to see that the file name is correct and everything is correct before downloading. And here, this is the index, the simulation index. So remember, I had like my simulation from 0 to 79. So if I run this code, it will process all of them. It will like download all of them. But let's see, I just don't want to do all of them. Let's see, maybe we select let's see this one, for example, like starting from number 23 to or maybe from like these two, like starting from 27. So I can download like, let's see, it showed for like, so I will download like 2 ensemble from this model, like R2 and R3, and I will download like 2 of these models. So that will be from 27 to 30, so that'll be 31. So okay, so we here like 27 and to put to 31. So I will pass this information to the download function, and you see here my download function now, it reads everything from the table. So the simulation information, that is now like, I don't have to write this manually now because I can read this from the table. So the activity, this is how you read from the table by the simulation index. So the index, so the index here, which it will start from 27, so it will pass like number 27, and it will go to this column which is named activity. So it will go to like activity, this is column, and number 27, so it would be reading this activity, like the high resolution MIP, for example. Institution ID, again, like it will go to this index and this column, like the institution ID, and it will be reading like this value here, and so on and so forth. So like you read the institutions, the source, the experiment, the member ID, the grid label, the version, and like the server, like where is the node, where this data is stored. So I think I put this here under the server. This will be like this URL, it will like read this URL, so it will go to this URL column and read from there. Start counting, like whether this file start counting from 0 or start counting from 1, and the year step, like how many, like how these files are saved. Are they saved by year, by 5 year, by 10 year? And the number of files, this is like some information, and the size, this is just some information for printing. So here it will, so I will first like print some information about what I'm doing. So, and then this is where to download from, and you see here like you just read everything from here, where to download to. Again, you read from here. This is the same code as above. The source ID, this is, I think we have to, so this the download, remember this flag was whether like you have a sub, like whether like the months start from 0 to from January to December, or like it's you have sub months, like you have to cycle through the months. So here, like, I just like made this one as an if condition because this is the only model in my ensemble of models where it do this sub-month cycle. So here basically I say if the source ID is this model, then this would be the list for my months. Otherwise, this would be the list for my month, like from 0 January to February. And then now we will like start to download so I will like go for like my file download. So I will be looping through different files. So this is the start period of my download, the end period of my download, and the year step. And here this is I will loop through the months. Again, for most of them it will be just like one of them, like this list. Other it will be like several, like you have to go like use this loop like 4 times. Okay, account for model group accounting instead of 0. So now, yeah, see here, like you see, I want to download the data from, let's say, 2010, but this model, it wouldn't have the data, like if I'm like that German model, it wouldn't have the data from 2010 because the file would be saved from 2011. So here, this will be accounting whether the model is starting from 0 or from 1. The last time step, again, I need to make this correction, which I showed before, like because all these models, they end in 2014. So if my last time step is going beyond 2014, bring it back to 2014. This is like correct for a single file because some of these single files, they have just everything in one file. So regardless of any range that I will define here, it wouldn't work because I just need to correct it from the start to the end. Okay, and here if you have any special cases that you need to account for. So for example, like this AWI model, it ends at 2010. So you need to account for this here. Again, like another special case, this AWI, it starts from 1951, so you need to ignore this year, like the year 1950, or sometimes they will have this year 50 just stored in one file, a special file for this, so you need to account for this special case here again. And you create the file name, so this is the same as we showed before, like how to create the file name. Again, here is another special case. This is like a third special case. So for this model, the head GEM3 medium resolution historic, it has a regular date range starting from 1970. So starting from 1970, you see they start like this. So they were like saving data 10 year by 10 year by starting from 1970. They start to have this like 7 year here, or then 10 year here, and then another. So it like have regularity. So this is a special case, for example, that you need to account for. And then like this is a regular download. Okay, so let's see here, for example, I will run it for these like 4 simulation and see if I will get something. Oh, I have to load this first. I have to load this function first because it's not defined, and now you can do this one. Okay, so now it tells me I'm downloading data for this model, this experiment, this realization. It has 65 file with this with about like 3.6 terabyte of data. And remember, I'm downloading this data just for 1 year. Okay, maybe let's do this for more than 1 year. Let's do it for 2 years. Okay. So I have, so now I'm doing this for 2 years. So this is for like year 2010. This is for year 2011. Like each file, I'm printing the data. Each file has like a 55 megabyte of data. This is for this model, like the same model but a different realization, like R3 instead of R2. And here I have like the same thing. This is the size of this data and for this 2 data. Then I move to the next one, like the ECMW model. This is like realization one. This is the size of this data, and this is the size of this file. So this is file for 2010, for 2011, and this is a different label. Okay, so now this seems that this function is working, and you can specify, like if you just want to specify a certain range of data. Like let's see if we want to add more model, like you can, like if you want to add more models, okay, to download, like now I'm running this for more model, like you see here now you have different model, like you see here, for example, like this model, like downloading the data of head gem, this high resolution model, the file size it has, like the data for this model is 68 terabyte of data, and this is like 3 months, like each file has a 3 months data, so you get like for the 2 year you get here, like this is the first 3 months, the second 3 months, the third 3 months, the fourth 3 months, so this is like 1 year of data. So you see, like for this file, because it's very high, like it has a nominal resolution of 10 kilometer, 1 year of data is just like 1 terabyte, and this is the other year of data is like another terabyte, okay. And then like while like this one, it has like just like 1 year of data is only 50 megabytes. So you see like a big difference in the size of data. Let's see if we have any other special case here. Okay, this one has like 9 files. So here, for example, like I'm only downloading 1 file because this has 9 files, because it seemed like 9 files. It's a historical experiment, so means that each file will has about like 20 or 25 maybe years of data, and I'm specifying only 2 years, 9, 10, and 9, 11. So it will download this file, like this file from 2010 to 2014. So that has like, it will have like these 2 years of data that I'm interested in. So again, like you have to carefully, like you have to do it carefully for each one of them. So you will like still download this one by one for each model, because you have to, there, as you see, like as you keep going through this list, you will find like this special cases. So for each special case that you will find, you have to account, like make special code for it, for each like special case, because like as I showed before, like this file, the range of time for this file could be like different. Here you can how to convert to from JSON to CSV. This is the link. What I will be showing next is like so this .nc file, this .netcdf file, how to access this file and do this quick visualization, quick access and quick visualization with Panoply. Okay, so that will be shown in the next video. Thank you very much, and see you in the next video.